Hello. So today's topic is nomenclature, organic nomenclature, and we will start with the simplest one. We will start with the alkane, and then we will discuss cycloalkanes, and then we will go to alkenes, and then we will discuss alkenes, alkynes, and functional groups. So this is the flow, and I want to make it simple and easy, as digestible as possible. So what I'll do is discuss a simple rule and then go to complex ones. So let's do it. First of all, let me tell you that we call the simplest of alkanes is methane. We call it methane. CH4, we call this one methane. Okay. And what do we call C2H4? We call it ethane. Okay. And what does the third member of this group? I'll write it in expanded form so it is easy for you people. Okay, we call this one propane. Let me take some time to make you digest these first few members, and from this on we will make the edifice for this. Okay, so butane, we call it butane. Okay, and the fifth member of this, we call this one pentane. Okay, and the sixth one is hexane. Okay, in the seventh one okay, so we must count the carbon number. This one should contain 7 carbons, 1 2 3 4 5 6 and 7. Okay, in the end, this is called octane. Okay, fine, no name. And the last one contains 10 carbon atom, and it is called decane. Okay, decane. Hope this is visible. Okay, so let me tell you something. Let me expand this one too. So this one is CH3, CH3. Okay, so this is also called homologous series of alkanes. Okay, straight chain alkanes, homologous series. Homologous series. You can see that there is just a CH2 difference between two consecutive members. So there is a CH2 difference between propane and butane. And there is a CH2 difference between pentane and butane. Okay, so one carbon to hydrogen increases as we go from one member to the other member of the same series. So this is also called homologous series of alkanes, and they differ by CH2. So this is not the main thing I want to mention. What I wanted to mention is that to tell you that there are two parts of this name. You could see them. One is meth and the second is ane. So I'm gonna elaborate this over here. The meth part and the ane part. This is called word root. Word root. Okay. So the word roots, we could see them over here, that this meth, eth, prof, but, pent, hex, hept, oct, and non. The first few members of them have been, their names have been derived from, they have some origin. And then the last ones, like from pentane, hexane, heptane to decane, these are numbers in Latin and Greece. Okay. So here the word root represents the carbon atom. Okay, word root represents the number of carbon atom. Okay, like for methane means one carbon atom. Okay, they could be C1, C2, C3, C4, and so on and so forth. Okay, and what does N represent? What is N? This N is my primary suffix. Okay, so this shows the carbon-carbon bonding. If there is single carbon-carbon bond between the molecules, is between the atoms of carbon. Okay, in these molecules you could see there are just single carbon-carbon bond. So this bond is single, this is single, all the bonds are single. So for such molecules, for such compounds, will write what? A in E. Okay, if there was a double bond present between the carbon in a molecule, then we would use ENE for them. Okay, and if there was a triple bond present between carbon in a molecule, we would use IN for them. Okay, so the primary suffix differs according to the bonding in carbon. If it is single, we'll use N as in these cases. So this remains the same, N. Okay, this means, so the profile of this molecule has been shown over here by this name very elaborately. It is very systematic way to name the compound. I can, by this name, I can infer lots of information. From the first part, I can infer the information about the number of carbon atom present in this molecule. And from the second part, I can infer the information about the bonding present in this molecule. Okay, I mean, if N is present, there is single bond between it. So now, to go further and carry on, we will discuss IUPAC nomenclature, the international standard for naming organic compounds. Okay, so IUPAC nomenclature has some rules, and we will discuss those rules with the help of examples. So there won't be just one suffix, there will be another suffix, and that would be for the functional groups. And there will come prefixes too, primary prefix and secondary prefix, but we will discuss them as the time comes. Okay, now we will carry on. Just you must look at over here. If you were to start from here, from one carbon and jump to another carbon, you do not have any alternative path. Okay, like here, a straight path over here. What I am trying to say that these are straight chains. Okay, an arrow could start from one carbon and end at another one, and I mean there is no one carbon present that has been attached to more than two carbon atoms. Like maximum, the carbons are attached to just two carbon atoms. So if you our highway has no branches, means this is just a straight chain. Okay, it goes straight. What happens to the naming if there is a branch to our main chain? Does the name change? We will see that. How does it change? How will we write the name then? Okay, now we will elaborate on then. But first of all, you must look at this chart and remember the names. Remember it forever. Like methane means one carbon saturated with sigma bonds of hydrogen. Ethane means two carbon, and propane 3, and bute for 4, and pent for 5, and so on and so forth. You must remember this chart. Okay, we will elaborate further on these. So as we learned that in our name there are at least two things. One is the word root, and for 4 carbon atoms, for 4 carbon molecule, it is bute. Okay, and for saturated molecule, we use N. So we learned these two things. Now I told you that suppose if there was a branch present in in this case, what will happen to the name? You must first of all nominate your branch. For nominating your branch, what you must do is, first of all, you must find your main chain. And main chain over here, I can count number of carbon atoms. The main chain should contain the greatest number of carbon atoms. Okay. So here in this case, this could be my main chain, and this could be the branch. Okay. So suppose this becomes my main chain. Now I must name my branch before I am able to name my main chain. Okay, the branch should be named first. So the branch here, I can see that the branch contains just one carbon atom. So for one carbon atom, I have learned the rule. I have learned that the word root for one carbon atom is meth. And now, as it is a branch for such molecule, it was ANE, the primary suffix. But here, as it is a branch, so there should be some change in the name too. So this could not be ANE. Yes, it is not ANE. What is it? It is YL. Means this branch containing just one carbon atom and bonded with single bond to my main branch is called methyl. Again, this substituent containing just one carbon atom attached to my main chain through single bond is called methyl. Okay, meth from the word root of one carbon atom, and YL is its signature. Like it represents that this is my substituent. This is a branch. YL is the representation of it. So now I know the name for my branch, and that is methyl. Okay, methyl. So I must write it before my word root methyl. Yes, I must write it. But should I mention the number of carbon atom to which it is attached? Yes, I should mention the number of carbon atom to which it is attached. So how can I number the carbon atoms? So IUPAC tells me that you should number the carbon atom from in your main chain from the side which is on which your substituents gets lowest number. Okay, so numbering should be done from the side in which the substituent gets rule. Substituents should get a lower number. By that I mean we should number our main chain from the side in which our substituent gets lower number. Okay, from this side we could see 1, 2, 3, and 4. My substituent comes on carbon number 3. And if I count it from this side, 1, 2, 3, 4. So my substituent gets number 2. So I must choose this side because from this side the substituent is getting a lower number. So I should take 2-methyl. Okay. So now I know to which carbon my substituent is attached. It is attached to carbon number 2. 2-methyl. And now I should try the basic rules which we have learned. Count the number of carbon atoms in the main chain. That is 1, 2, 3, 4. 4. So for 4 we know the word root is but. And as this is all saturated, so N. So our name becomes 2-methylbutane. But here I am gonna tell you one more rule, that between number and word we write hyphen. We put hyphen. okay, between a number in IUPAC nomenclature, between a number in a word, we put hyphen to distinguish between, to give space between a word and a number. We must put hyphen. Okay, this dash, this is called hyphen, and we must put it in between them. Okay, if there were more than two substituents attached, like suppose in this case, again, one methyl group, we now know what is methyl group. Now we know this is methyl. Okay, we have learned the name. So two times there are two methyl groups attached now. What should I name this compound? How should I name this compound now? Now I know the basics. Okay, I should start from the end. You must listen to me carefully. I should start from the end, which is nearer to our substituent. So from both ends, we have the substituent on carbon number 2, from this in 2, from this in 2. So equal, okay? No priority to anyone. I can start it from any side and I will have the same name. Okay, now, what should I name? How should I number? I should number it 1, 2, 3, 4. So my main chain has 4 carbon atoms and it has 2 methyl groups attached at carbon number 2 and carbon number 3. So I must mention the number of carbon atom before the name of the substituent and that before the name of our parent chain. Okay, so 2, 3. And 2 times methyl group is attached. So hyphen dimethyl. Okay. And what is the name of our parent chain? That does not change. So it contains 4 carbon atoms. So the word root would be buta. And as it is alkane, so A and E will end our name. So 2,3-dimethyl butane for this compound. So let's suppose if both our methyl groups were attached on the same carbon atom, okay? If the same methyl group was attached on both on the same carbon atom, okay? CH2 and CH3 over here. This CH goes because carbon can form just 4 bonds. Okay, now what would be the name of this compound? So now both methyl groups are attached at 1 carbon atom, from which end we should number this compound. In my view, in your view, now logically we should number it from this side 1, 2, 3, and 4. As we have learned the rule now. So now, should we mention the number 1 time or twice? We should mention the number of carbon atom to which 2 substituents are attached twice. Again, we should mention the number of carbon atom to which 2 substituents are attached twice. So we should mention 2 twice, 2, 2. And between the numbers, I'm putting comma. You must give heed to this. So 2, 2 and dimethyl butane. Okay, so we learned about comma. Comma is put between numbers. Okay, what are the punctuations of IUPAC? IUPAC punctuations are comma and hyphen. So comma between numbers and hyphen between a number and a word. Okay, now I will change this compound a bit and tell you and ask you to please name that compound for me. Okay, I will rub this off and change a bit in this compound. You must try naming this compound. Okay. Now, what you should do is, in this case, that write the numbers from both sides. From this side, my what am I getting is 1, 2, 3, 4. Okay. But you are doing this wrong. I knew that, because this is not your main chain now. Okay. Now your main chain turns to be 1, 2, 3, 4, and 5. Okay, now this becomes your main chain. The main chain could not always be a straight one. Okay. So now this is our main chain. Our main chain contains what? 5 carbon atoms. So now you should name this compound, and we know that there are 3 substituents attached. All of them are methyl, so we should mention their numbers before their names. It is twice on 2 and 1 time on 3. So I am getting 2, 2, 3 trimethyl, and now the word root is pent in this case, and A and E for. Okay, now we are done with it. I will go forward and change a bit in this structure. Now you must name this compound. Okay. So now I hope you have done it. Now let's try. So we must number the or first of all we should take our main chain. Which one is our main chain? So suppose we take 1, 2, 3, 4, 5, 6, 7. This one could be our main chain, or 1, 2, 3, 4, 5, 6, 7. This could be our main chain. Suppose this one is our main chain. Now look at the substituents and number the carbon atoms. So I can number this compound, our main chain, from this side 1, 2, 3, 4, 5, 6, 7. Or from that side I can number it. So the numbers would be 1, 2, 3, 4, 5, 6, and 7. So numbering it from this side, I'm getting the substituent on 3, 3, and 5. And from that side, I'm getting the substituent on 3, 5, 5. So which one gets priority or which one? So the one with the lower number of locants, we will look at the first side of difference. So here we have got tie 3, 3 in both cases, but in the second case we can see that in the upper case I have 3, in the lower case I have 5. So I must opt for the lower one, that is giving my substituent a lower number. So I'm getting the sequence that is giving my substituent a lower number. So 3, 3, 5, I'll get this sequence. Okay, so I must remove the numbers from the lower side. So what will be the name of this compound? I must mention the number of the substituent before the name of the substituent. So I am getting 3, 3 dimethyl, and I am getting 5 ethyl. So here 5 ethyl. So here is another rule. When there are 2 substituents having different names, I must write them in alphabetical order. So E comes first from M. So in alphabetical order, E comes first and M later. Okay. So do we consider D? No. A. We do not consider the di or tri of the number. Okay. Di and tri are not considered in alphabetical order. Di or tri are not considered. Okay, we should follow alphabetical order in writing the name. The final name would be 5-ethyl 3,3-dimethyl. And what is the parent chain? The word root is hept. And A and E for, let me change this a bit. Okay, now you must name this compound. So there is now a bit of tweak, a bit of change in this compound. Now, if I were to count the number of carbon atoms in both, from both directions, I have the substituent attached at the same number. From this side, I'm getting the number 3 and 5, and from that side, I'm getting again the number 3 and 5. So I have got a tie in both cases. So the numbers are now equal. What should I look for? When the numbers are equal, then look at the alphabetical order. Now we must look at the alphabetical order. And what does the alphabetical order tells us? Alphabetical order tells us that ethyl come first, then methyl. So we must give preference to ethyl and give it a lower number. So we must number this compound from this side 1, 2, and 3, 4, 5, 6, and 7. Okay, so what will be the final name of this compound? It will be 3-ethyl 5-methyl heptane. Okay, we do a bit of change in this compound and ask you to name this compound. Now you must number and name this compound. So now we have the option to opt for the longest carbon chain. So here I'll discuss the longest carbon chain rule. Okay, I have two options. One is to select this one is our longest chain containing 6 carbons. Okay, 1, 2, and 3, 4, 5, 6. And it could also be like this one containing 6 carbons. Which one should I opt for? Here is the rule. Opt for the longest chain that contains greater number of substituents. Greater number of substituents. Okay, so which one gets us more number of substituents? This one. And why are we opting for this? Why is IUPAC giving us this rule? It is giving us this rule because it gets the name cleaner, because we are now free from getting into a complex substituent. If we were to opt for that one, like the black box, what would we get? We would get a complex substituent, and naming that would be a bit difficult than naming more substituent. So we are opting for the chain that contains greater number of substituents. So here we should mention the substituents by the number of carbon atoms to which they are attached. So here we have to number the carbon atoms. So 1, 2, 3, 4, 5, 6. Again, the rule remains the same. We must mention ethyl before methyl. So on carbon number 3 we have ethyl, 3-ethyl, 2-methyl, and Higgs, and A and E. Okay, I hope I have cleared up my point. Okay, now if there was a complex substituent, what will we do? Okay, suppose there was a complex substituent. Now we'll discuss some rules for that too. Okay, now you must name this compound. So first of all, we must take our main chain that contains greater number of carbon atoms. So 1, 2, 3, 4, 5, 6. No, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So this will become our main chain. Now the substituent attached seems to be a complex one. So what is the rule for it? The name of the complex substituent must be closed in parentheses, okay, in the brackets. Now, after that, the carbon that is attached directly to the main chain becomes carbon number 1. Now we should take our way out of this carbon toward the longest chain. So each side contains just one carbon, so we can go either side. So suppose I am giving this one carbon number 2. So these two are substituent attached to the main chain of our branch. And what would be their name and their number? So they are attached at carbon number 1. So carbon number 1, 2 branches, and both are methyl. So I have got 1, 1 dimethyl. Now, I must mention the main chain of my branch, that is 2 carbon atoms mean ethyl. And as this is branch 2, so this becomes ethyl. So this name is made up of 2 names. One is dimethyl and the other is ethyl. This dimethyl is the branches of my branch. These dimethyls are the branches of my branch, so they must be mentioned before I mention the main chain of my branch, and that is ethyl, made up of 2 carbon atoms. Now is the tricky part. So we have already learned this, that we should number our main chain from the side that is nearer to our substituent. So from this side 1, 2, 3, and 4, and from this side 1, 2, 3, and 4. So from both sides I'm getting it on number 4. So this substituent, this complex substituent, which is being enclosed in the parentheses, is present on carbon number 4 of my main branch. So what are the total number of carbon atoms present in our main chain? 1, 2, 3, 4, 5, 6, and 7. Heptane. So this is the name for our complex substituent. Now we will go toward the cyclic compounds, but before that, I must tell you how to draw the bond line notation for carbon chains. Okay, so let me draw the bond line notation for this compound. It will become like this. Okay, each end, like this crust and this trough, and this whatever crust or trough, they represent carbons. So here is a carbon present with enough amount of hydrogen to saturate it. Here again, here again, here, and here, here, and here. Okay, 1, 2, 3, 4, 5, 6, and 7. So the above compound could also be written like this. Pretty easy for a chemist to write, okay? We'll get into the cyclic groups, okay? The cyclic compounds. So what is this? This is a compound having 3 carbon atoms present in a cycle, in a ring shape. One carbon attached to another and another to another, getting us a cycle, giving us what? A cycle, a cyclic form, a cyclic shape. So this is called cyclopropane. Why propane? Why cyclo? Cyclo because this compound is cyclic, and why prop? Because 3 carbon atoms are present, and why N? Because all bonds are single. There are single bonds between the carbon atoms. So for a single bond, we have the suffix of A and E as we have learned it. Okay, where does the cyclo word comes from, and where should we mention it in our sketch, our skeleton? So as I have mentioned secondary prefix, but I have not mentioned primary prefix. So this becomes our primary prefix. So plus primary So before word root, that is prop, and suffix, primary suffix, I must mention my primary prefix. So the word cyclo is my primary prefix. My primary prefix should be mentioned after secondary prefix and before the word root. Okay, so in this case, suppose I had a methyl group attached over here. So the name could be methyl. It is understood that it is present at carbon number 1. So it is methyl cyclopropane. 1-methyl cyclopropane. Okay, meth is, what is methyl? Methyl is my secondary prefix. What is cyclo? The word cyclo is my primary prefix. And what is prop? Prop is the word root. And what is A and E? So N is what? N is my primary suffix. Have not discussed double bonds or functional groups, so we will not go to that. Up till now, we have just discussed simple hydrocarbons, okay, simple alkanes. So in this case, if we have the option between the cyclic ring and a straight chain, cyclic ring, okay, in a straight chain, which one should become our parent chain? So that would be decided by the number of carbon atoms. Greater the number of carbon atoms, the one which contains greater number of carbon atoms would become our parent chain. And if both have equal number of carbon atoms and no substituent attached, so then the cyclic would be our parent chain. Again, if no substituent attached, no other substituents attached to either of them, and both have equal number of carbon atoms, so the cyclic one would be the parent chain. Okay, now in this case, you have to name this compound. We can name this compound from either from this side or this side. So from this side, the cyclopropyl gets carbon number 3, and from that side, the methyl groups comes at number 3. So which one should we choose? Now here we should look at the alphabetical order as we have learned. So the cyclo C comes first, then the methyl M. So we should number it from this side: 1, 2, 3, 4, 5, and 6. Okay, so what would be the final name for this compound is 3-cyclopropyl 4-methyl hexane.